Okay, guys, so here is this. AP Calc Cycle K Phase 7. The practice for this is on Delta Math. Okay, so these are all from Delta Math. I'm going to do 3 examples. This is going to go really well for you, I think. So basically, guys, we're using a technique called U substitution. And that might sound familiar because in Algebra 2, you used U substitution for other things. U substitution is a method that is used in math that just takes a complicated problem and turns it into one that is easier to work with, or one that you know how to work with. So basically, guys, if a derivative was taken, so U substitution is essentially chain rule backwards. Okay, so like the whole in and out thing. So U substitution is chain rule backwards. Now U substitution can be used in other contexts as well, but usually when we're using it in AP Calc, it's basically chain rule backwards. And guys, when you're doing chain rule for derivatives, the key to doing chain rule is to figuring out the inside function. All right, that's like the big key. So same thing with U substitution, which is chain rule backwards. You just have to figure out what the inside function is, and then you let that be U. Okay, so we're going to look at this. So I'm going to do this antiderivative. All right, so calculate the integral. It's the same as an antiderivative, and express your answer in simplest form. So guys, we want to take this integral. We want to take its input, which is currently 18 over x plus 5 to the third. And we want to let u equal the inside function that is involved here. All right. And if you see, guys, this x plus 5 is being raised to the third power. So x plus 5 is the inside function. All right. Inside. It's inside another function. So this is 18 over u to the third. Okay. But guys, right now, this is basically asking us, everything needs to be in terms of u. All right. This variable here that's at the end of the integral, that needs to match the variable that's on the input. Okay. The input variable of the integral has to be the same as the variable at the end. So we want this to be du. And this is why we practiced last phase. So du, oh, look at this. Oh my gosh, that's wicked easy. In this case, du is equal to dx because the derivative of that is just 1. Gosh, that'll happen sometimes. So this is 18 over u to the third du. And guys, you can use the power rule for antiderivatives on this function inside here if you write it in the form ax to the n. So I'm just going to change this to 18 u to the negative third du. All right. And then this is, okay, so this is 18 divided by, the new exponent is going to be negative 2. U to the negative 2 plus c. That plus c is important. And the very last step, guys, is to put the u back in. So this is negative 9. U is x plus 5 to the negative 2 plus c. We did it. Okay, so that is how you do an integral or an antiderivative with what's called u substitution. So basically, if you look at the input of the integral and you see, and it's really complicated and you see functions inside of other functions, then you need to try this u substitution. Okay, let's do this one. So I look at this, I have no idea how to find the antiderivative of this input on the end of the integral, but I do, so I know if I don't know how to find the antiderivative, I can't think of a formula, I can't use power rule, then it's probably u, let's just say it is u substitution, okay? So I look at this carefully and I say, is there an inside function? Is there a function that is inside of another? And I see, if I ignore this 5x, I see that this 6x squared plus 5, that is inside of this fourth root function. So that sounds like a good u. So I can let u equal 6x squared plus 5, right? And then this becomes 5x, and then the fourth root of u over 4 dx. Now, we need two things to happen. So this needs to be written completely in terms of u. We need two things to happen. We need this dx to turn into a du, and we need this x to cancel. Okay, that x needs to cancel. So that's where you do this thing. You go du equals, you take the derivative, which is 12x dx. And then so dx, oh, this is going to work, is 1 over 12x du. So dx is this. So this is going in for dx. And guys, while I'm at it, I know, like the fourth root of u, I know eventually to take the antiderivative, I'm going to need to use the power rule for antiderivative. So I need ax to the n form. So I'm going to make this u to the 1/4 right away. All right, so this is 5x u to the 1/4 over 4, and then 1 over 12x du. Okay. And these x's cancel. All right, those x's cancel. And guys, you can gather up the constants and bring them out front. So I'm going to have on the top 5, a constant multiple of 5, and the bottom, what is this? That's 48. So it's going to be 5 48ths. So 5 48ths, you can bring any constant multiple outside of an integral. Okay. So I just carry down this 5 48ths. Maybe I should have left it inside. I don't know. Okay. All right. So now, I brought down the 5 48ths. Right. That's like a 1. So on the inside, so this is going to be times 1 divided by, so 1/4 plus 1 is 5/4, because 1/4 plus 4/4 is 5/4. So 1 over 5/4 u to the 5/4 plus c. All right, and then this is equal to, all right, so I do keep change flip on this, guys. Let me go up here. So this is really 5 over 48 times, keep change flip on this gives you 4/5. Oh, that's nice. So those 5s cancel, and then this ends up being 1/12. Okay, right? Seems weird, does it? I think that's right. Yeah. Okay, so that's what this out front becomes. So this is 1/12. Now the very last step is the u has to go back in. Okay. Let's do one more. Oh, and guys, your notation has to be perfect when you're taking this AP test, because it's all free response. So they're really going to be looking at your notation. My cat Walter is playing with, see his little paw. I'll just show him to you. Hey, Walter. Thanks for the help, buddy. Okay. Yeah, so your notation needs to be very proper, very, very strong, because it's free response. And so they're going to be looking at the notation. All right, so down here, I don't know how to take the antiderivative of the input of this integral, but I do see that 2x to the 3rd plus 3 is inside of blank to the 7th. So I'm going to let you, guys, and I'm going to show you something that will make this go maybe a little bit faster, okay? So u is equal to 2x to the 3rd plus 3. Stop. Walty, stop. 2x to the third plus 3. Okay, and then right away, so I've identified the u, so right away I can go du equals 6x squared dx. Dx is 1 over 6x squared du. So you can do the substitution all at once. Like before I was like putting the u in, and then I was putting the du in. And and that just is extra writing. Okay, so I'm going to put the u and the du in at the same time if I do all of this first. All right, so this is equal to the integral 12x squared. And then this is u to the 7th. And then in for dx is going 1 over 6x squared du. Okay, so these x squareds are canceling. And this time I won't pull the coefficient out front. So this is the integral of 2u to the 7th du. All right, so those canceled. And then the 12 divided by 6 is 2. Okay, so antiderivative time. I bring down the 2. 7 plus 1 is 8. U to the 8th plus c. 2/8 is a 4th. 1/4. And the u goes back in. Okay, guys, so there it is. You can do this. Do tons and tons of practice. You're going to be so good at this.